pure substance. Um, let's try this one. We have a whole new batch of things. So really quick, pause the video, write down what you think each of these is. Is it a pure substance or is it a mixture? If it is a pure substance, tell me, is it an element? Is it a compound? Perhaps it's a molecule, right? So tell me what you think each of these is. I will give you a second, pause the video, see if you can figure these out. Okay, so this first one is a pure substance and it is a compound, right? Because we have two different elements bonding together. This second one is also pure and it is also a compound, two different elements bonding. Again, pure here. We have three different things bonding, right? But it is the same molecule or same compound repeating. This is a mixture, and it would be a mixture of two different compounds, right? Methane and ammonium. This is a pure substance. This is elemental, right? It's the same element bonded to itself. Pure substance, and it's elemental because it's sodium over and over again. This is a pure substance full of compounds. Again, pure substance full of compounds. This would be a mixture. We have two different things. This would be an elemental mixture, right? Because it's elemental nitrogen and elemental oxygen. This is a pure substance of elemental hydrogen, pure substance of elemental oxygen, pure substance of elemental nitrogen, pure substance of water, which is a compound. This would be a mixture of three different things, a compound into elemental things, and then this would also be a mixture of compounds. So, mixtures. There are two types we're going to worry about right now. You can see here something is different between these two. What is different? If you look at this picture here, this mixture looks the same everywhere. It has a uniform composition throughout, right? So when you're looking at it, it looks the same everywhere. The things are not separated. The sugar is moving in and around the water molecules, whereas this one is non-uniform. The things are not really mixing that well, right? There is a boundary, and even if you like shake up oil and water, eventually the oil will separate and go to the top, while the water will go to the bottom. So this one on the left is called a homogeneous mixture, and it has a uniform composition and uniform properties throughout, right? So, excuse me, sugar water is the same throughout, whereas this one is different throughout. It is not uniform, and that means that its properties are not the same throughout. So this is like seawater, also like alloys of metal, and then oil and water is a great example for heterogeneous mixtures. So if we have a mixture, we also are going to want to be able to separate it. So there are lots, oh man, excuse me again. There are lots of chemistry techniques that we can use to separate a mixture. And we're not going to go super in depth right now because I'm kind of running out of time on this video. But I wanted to show you some. So here's some mixtures over here. And then here's some techniques that we use to separate them. And we can separate mixtures because the parts of the mixture do have differences in properties, right? So like if you're thinking about sand and salt, their difference is that one of them is soluble in water or dissolves in water, which is salt, and sand will not dissolve in water. So if you have a bunch of sand and salt mixed together and you put that into water, then the salt will dissolve into the water and you can take the water away. So that will leave you with just the sand, and then you can separate the salt from the water too by evaporation, right? So solution and filtration, that means you're putting this mixture into solution, putting it in water, and then filtering it. So you're separating the water from the sand. Salt and water, right? So if we then wanted to get the salt out of the water, their difference in property is their boiling point. So if we heat up the water will boil away before the sand boils, or the salt boils, sorry. So this technique is called distillation. If we have a mixture of iron and sulfur, their difference in property is magnetism, right? Iron is magnetic, sulfur is not. So we put a magnet near our mixture and we will begin to draw out our iron. If we had like a mixture of pigments and food coloring, the difference in property there would be absorption to solid phase. So we would use something called paper chromatography, which we'll do this experiment. It's really fun. And you can get the pigments, the colors, to come out because they absorb at different rates into solids. So there are lots of techniques we can use to separate mixtures. We will do some of them in class. Sorry, I'm not there this week to do them with you. That's the fun stuff. But just know that it's possible, and we are going to talk about it and do some of these and learn about it. And these are really valuable techniques, especially as you start thinking about the real world and like even like industry and production. Like oftentimes you are getting things that are mixtures and you need to separate them to get what you want. Or like if you want to distill a new color or something to put into a product, you often need to use some of these techniques to get the color that you want or to get the thing that you want to add into your next step. So here's a nifty little graphic that kind of summarizes everything we've talked about today. This is all matter, so everything that has mass, right? All matter. It can be separated into pure substances or mixtures. And pure substances we can think of as either elements, or the elemental molecules, and compounds, which is multiple elements combined together. And then mixtures are either heterogeneous, right, which they're not uniform, they separate, or they're homogeneous. They are uniform, and you can't really tell the difference between them. So, quick check. Which of the following are homogeneous mixtures? Think about this carefully. Your options are coffee, smoke, and vinegar. So choose one of the multiple choice answers below. This is like a question you might see on the IB test itself. So take a second, pause the video, think about your answer, and then I will talk about it. So the correct answer is 1 and 3 only. So C is the correct answer. If we think about it, right, coffee is homogeneous. When you look at it, you can't see any difference. If you leave it out, it will not separate. Same thing with vinegar, right, pure vinegar. But smoke is considered a heterogeneous mixture because we can see the individual smoke particles under a microscope, right? When you burn something, you can see those particles rising up into the air. So I'd like you to practice these questions as well. So outline the difference between homogeneous and heterogeneous mixture. Again, this is like a question you might see on the IB test. And then classify each of the substances below as element, compound, or mixture. So pause the video, answer these 2 questions, and then I will talk about it. Okay, so number 1, outline the difference between a homogeneous and heterogeneous mixture. A homogeneous mixture has a uniform composition and uniform properties throughout, right? Heterogeneous is non-uniform and non-uniform properties. That's exactly like what was on our slide. You might have put that in your own words. That's totally great, but something to that effect. Now let's classify each of these as element, compound, or mixture. Water is a compound. 2 hydrogens and 1 oxygen make a water molecule. Iron is an element. You can find it on the periodic table. A sodium chloride solution. So that would be like salt dissolved in water. And this would make a mixture, right? Because we have water and we have sodium chloride. Brass. Brass is also a mixture. Oh, and this would be homogeneous, right? Brass is homogeneous as well. It is an alloy or a mixture of copper and zinc. And you cannot tell the difference when you're looking at it, right? It's all one thing. And then seawater is also a mixture, a homogeneous mixture, and it is salt water, right? Salt dissolved in water. Okay. So here is something to think about. I'm going to link this video. It's really interesting. And you can do this part after I've got a worksheet for you that you're going to look at. So after you're done with the worksheet, if you've got time and you are interested in this, I want you to think about these questions. But could there be more than 118 elements? That's how many we've discovered so far. The newest ones we've discovered are super unstable. They only exist for like fractions of a second. But this video talks about a theoretical island of stability. So, kind of thinking about, can we make bigger stable elements? It's really interesting. So I'll link this for you after you're done with the worksheet. Take a look at this video and think about these questions. I'm so sorry I couldn't be there today. Hopefully I'm there very soon. But I look forward to meeting you in person and continuing to talk about chemistry. All right, see ya.